let me work out an example of area between curves. Suppose that we want to find the area between the functions f of x equals x squared and the function g of x equals x to the fifth. Well, the first step that we need to take in here is to sketch the graph of these two functions. So what we have in here is that x squared is a parabola like this, and x to the fifth is going to be a function that looks a little bit like that. You can double check the graphs on the graphing calculator or in the many online tools that are available over there. In other words, this problem is asking us to find the area of this little part in between of these two shapes. So in order to do this, we need to find these two intersection points. That would be our first part. So these intersection points are basically where the functions are equal to each other. In other words, f of x equals g of x. So here what we have is x squared equals x to the fifth power. Now, in order to solve an equation that looks like this, what we need to do is we need to put everything on one side and then factor our expression. In other words, this would be the same thing as saying x to the fifth minus x squared equals 0. It's very important not to cancel the x's in here because we can lose some intersection points. So we can factor this expression. I can take an x squared as a common factor, and then we will have x to the third minus 1 equals 0. That means that either x squared equals 0 or x cubed minus 1 equals 0. From the first equation, we get that x equals 0. That's our first point, our first intersection point. And then from the second equation, we get x cubed equals 1, and taking the cube root, that gives me x equals 1. Remember that we don't have plus or minus in this case because that happens only if the power is an even number. In this case, it's an odd number, so I only have one solution. In other words, this tells me that the two intersection points that we're looking for are x equals 0 and x equals 1. So with that information, I can actually come and write down the expression for that area to be the integral between 0 and 1 between our intersection points. And then we take the difference of the two functions. So remember, we always need to take the top minus the bottom. In this case, the top function is the x squared and the bottom function is the x to the fifth power. In other words, this should be the integral of x squared minus x to the fifth dx. Now, on a practical sense, if you're not clear which one is on top and which one is on bottom, if whenever you work out your integral, you end up with a negative number, that means that you picked the wrong number, the wrong order for your function. So the only thing you have to do is to flip the sign. In other words, if I would get negative 2, that means that the actual answer would be positive 2. That means that the only mistake I can make is up to a sign. So it's pretty convenient. So I just have to do the antiderivative for this expression, and that will give me x cubed over 3 minus x6 over 6 and everything between 0 and 1. So I can evaluate this expression. Everything at 1, that will be 1/3 minus 1/6. Minus everything at 0 would be 0 over 3 minus 0 over 6. And this will give me just 1/3 minus 1/6, which is the same thing as 2 over 6 minus 1 over 6, which is 1 over 6. That means that the area between these two functions is going to be 1 over 6.